Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we are looking at our Semester 1 review. Okay, this might be in two parts, so make sure you watch both videos as needed. First one just says solve. That should be a problem that we are used to. It looks like you got variables on two different sides. Get them on the same side. Once they are on the same side, just move everything away using our inverse or our opposite operations. So on this one, you should end up getting that x is equal to 3. Second one, same idea. You've got a problem and it just says solve it. So just start by solving it. I know some people get confused by the graph. Ignore the graph at first if you want to. Distribute, you can move the values away. And one thing to note, we have an inequality here. Whenever you have inequalities, if you multiply or divide by a negative, like that step I just showed, that means that your inequality sign is going to change directions. Notice it flipped here. This is our answer. We just need to graph that. So above -7, we're going to need an open circle in this case. It is an open circle because we do not have an equal to part. The inequality sign will show you where your arrow should go. In this case, our arrow is going to the right. We have our answer for 2. Number 3, find the rate of change. If we're looking at rate of change, you need to know your rate of change formula. y2 minus y1 over x2 minus x1. All I have to do is find the rate of change on this interval. Remember, if they're giving you an interval, they're giving you two different x values. This is an x1 and a y1. If you look at our table, you would notice those here. Well, if they give us the x1 and x2, that means that this must be the y1 and y2. So now it's just plugging into your formula, giving us this. Type it into Desmos if you need. You'd get -7/2 or -3.5. Now we have our answer. The fourth one says write the equations in slope-intercept form. Again, that one might be a little bit weird. We may have forgotten that, but all you need to do is write it like that. Meaning if it doesn't look like that, rearrange it. Move stuff around so that it changes to look like y equals. So maybe I subtract the 5x on both sides. But I need to get the y by itself. It's y equals. So divide the -3. Notice I'm dividing that separately on the right side. The reason I'm going to do that is because 18 over 3 gives us a value of 6. And now I have it simplified. I have the m is 5/3 and the b value is 6. Number 5 says write the equation in slope-intercept going through those 2 points. You've got 2 coordinates here, x1, y1, x2, y2. First thing you should do is find your slope. So in this case, 3 minus 7 over -6 minus 2. If you were to type that into your calculator, you'd get 1/2. From there, we need to use point-slope form. Point-slope form, you only ever replace 3 things when you are using it to create the equation of your line. So instead of y1, I replace it. Instead of m, I replace. Instead of x1, I also replace. Once we have that, you do want to change this form. So you might want to distribute to get rid of the parentheses. You might want to add the 7 over to get y by itself. And now you've got 1/2 x plus 6, which is in slope-intercept form, just like the last problem, just manipulating that equation. The next one says solve the equation by graphing. Remember, a solution to a system when there's more than one equation is where those 2 lines cross. So in this case, you would find on Desmos, they intersect at 3.3 repeating and 3.6 repeating. Those are the 2 values, that is your x and your y in your solution. Number 7, you can use that same idea where you're just solving by graphing the system. If you were to do that for this next one, you would find that your 2 lines are crossing at the coordinate -2, 1. You would find for b that you graph 2 lines, and those 2 lines are directly on top of each other. When lines are on top of each other, they have infinite solutions because they are crossing everywhere. And for C, if you were to graph that one, you'd find 2 lines that are next to each other that are parallel. That means there is no solution. These lines will never cross. There's the first 7 problems for you. Let's keep moving on to another few. So from here, looking at number 8 now, it says find the average rate of change. Okay, well, it's rate of change. Again, you need your rate of change formula, which is just our slope formula. So we do need to utilize this equation, but we need to figure out what the values are. Again, you're given an interval. These are the x values then. So I know the bottom of my fraction is 2 minus negative 1, but I don't know the y values. In order to find the y value, what you could do is you could plug into the equation. Okay, so we're finding y1 on the top. We're finding y2 in this bottom case. If you type those into Desmos to find these values, you end up getting out a value of 6 for the first one, which again is the y1, and you get a value of 3 for the bottom one. You could plug those in to give us 3 minus 6, type it into your calculator, and now you have your rate of change. Again, we had y1 and y2 there to find the slope or the rate of change. Evaluate these complex numbers. Evaluating is, in this case, just telling us to simplify. So if I've got 2 parentheses adding with nothing in between them, there's a plus sign between them, but there's nothing to distribute. That just means that my parentheses can go away, and I can just combine the like terms. Negative 7 plus 2 gives us negative 5. Combine the I like terms, which gives us negative 11i. It works the exact same as just combining normal values. When there's a minus in the middle, you do need to distribute it. When you distribute a negative, that means the signs change. The 8 is negative, the 2 is positive. Again, combine your like terms. 9 minus 8, 1i plus 2i gives us 3i. And part B there is done. Part C is now when they are multiplying. That one might be a little bit more challenging just because now I have to multiply a few things. It'll take another step or two, but it's nothing too terrible. We've been doing a lot of multiplication throughout the year. Set up the multiplication, multiply it together, and you end up getting something like this. I times I is I squared. Well, one thing we need to know is what is I squared. I squared we learned earlier in the year is the same thing as negative 1. So from here, I could still combine my like terms, the 15 and the 4 combined to negative 19i. But the other thing I'm capable of doing is changing I squared. We said that I squared was the same thing as negative 1, so I get rid of it. I replaced it in parentheses with that negative 1. And all that's going to do is it's just going to multiply the negative 1 with the 20, giving me plus 20. Well, when you do that, that gives you new like terms. Negative 3 plus 20 now gives me 17, and the 19i is still there. Now I have my final answer. Let's look at number 10. Number 10 says solve the following quadratic equations. Depending on what your quadratic looks like determines how you solve it. This first one says use the square root property. That just means get the x by itself. The reason we are able to get x by itself in this case is there is only a singular variable. There is only an x squared term. There were no other x terms. So I can get this x by itself, subtracting 8, dividing the negative 2 over. And now since x is being squared, we take our square root on both sides. Remember, when you take a square root on both sides, you always get plus or minus. Square root of 25 is 5, and since it was negative, you get I as well. 10b, solved by factoring. Notice x squared and x, that's why I'm not able to get x by itself, so I have to use a different method, which is factor. In order to factor, there's 3 terms. That's our ABC method. Find what multiplies to a and c. Find what adds to our b value of negative 7. In this case, I believe you'd find values of negative 9 and 2. Since your a value is just 1, we are allowed to take our shortcut, go straight to the factored form, where we have x minus 9 and x plus 2. You could separate those, set those both equal to 0, and solve. You'd get x equals 9 and x equals negative 2. That one is complete. 10C, solve using the quadratic formula. Quadratic formula is one of those things that will be given to you. The formula, though, looks like this. This is how you'll see me get each of these values and know where to plug in. We have negative b, so there's my negative sign. Plug in my b value. Plus or minus square root of b squared minus 4 times a times c all over 2a. When you are simplifying this, you only need to type in what is underneath the square root into Desmos. That is your first step. So type in what's underneath the square root. You'd get a value of negative 63. And on the bottom, 2 times 2 gives me 4. One thing I notice is the square root is negative, so maybe you take the I out and you get something like this. That would be a fine answer for me. The answer on the back of your packet, though, says they simplified the square root of 63. They found that 9 and 7 went in, so they changed that part to just be 3 root 7, and it's still all over 4. There's our answer for C. Continuing, it says, what are the x-intercepts? That's something you can find on Desmos, right? That's a graphical feature. You could just graph to find the x-intercept. If you want to do this by hand, though, you can always find x-intercepts by taking the factors and setting those equal to 0. So you could take x plus 3 equals 0 and x minus 4 equals 0 and just solve both those. What you'd end up finding is x is negative 3 and x is 4. Number 12 says end behavior. That means I need a graph of this. You might graph our equation here. If you graph it, it would look something like this, where I notice that the left side is going up and the right arrow is going down. Remember, end behavior, you only care about the sides. You always need to reference which side you are talking about first. So for example, if I say x goes to positive infinity, that means I'm talking about the right arrow. X is positive on the right side of a graph. The second part is, where does the graph go? Where is your arrow going on the right? On the right side, we noticed it was going down. It would go down to negative infinity. The second one then, x goes to negative infinity. That means it is going to the left side. On the left side, we said that our graph was going up. Up is the positive y direction. There's our answer for number 12. Number 13, given the following graph of a polynomial, determine the following. One thing we talked about is end behavior. And end behavior has two parts. One that is the degree, which tells you even versus odd. And one that is the sign. And the sign tells you whether it's positive or negative. We learned that even degree always has both arrows going up. An even degree that is negative has both arrows going down. Odd degree, the arrows will go different directions on the ends. If it is positive, the right side goes up, the left side goes down. If it is negative, those two would end up switching. Well, what I notice about number 13 is both the arrows are going in the same direction, so I know that it must be even. Since they are both going down, I know that it would then also be negative, even and negative. Looking at 14, it just says simplify. We can do that. We can distribute our negative to the inside, negative 4x to the fifth, minus 3x squared minus 7. Remember, when you distribute a negative, all of the signs change. And then just combine your like terms. X to the fifth, you have two of them. You can combine them to give you negative 7. You can combine the x squareds as well. And you can combine these other values at the end. That's all I'm going to get through in this video. Please pick back up on the next video where I will talk about the second half, 15 through number 27.